Good morning, my dear friends. See now, we will go to the third problem in this shear. Okay, I will just read this problem. A concrete beam of rectangular section 200 mm by 600 mm. Okay, 200 mm is this and 600 mm is the depth. Is pre-stressed by a parabolic cable. Parabolic cable is there now. Okay, located at an eccentricity of 100 mm at midspan and concentric at the support. Okay, at center it has got an eccentricity of 100 mm. Okay, I think you can see it 100 mm, and at the ends it is concentric. Concentric means eccentricity is 0. Okay, it it exactly coincides with the CGC. Okay, eccentricity is 0 at the ends. He says, okay, the beam supports a UDL of 4000 Newton per meter. In a sense, it carries a UDL of 4000 Newton per meter or over and above the sulfate. Okay, find the effective force necessary in the cable for zero shear stress at the support section. In a sense, he has asked you to calculate the effective force necessary, in sense, effective pre-stressing force required in the cable for zero shear stress at the support section. Okay. For this condition, calculate the principal stresses at the support section. Okay, he has asked you to calculate the principal tension also. The span of the beam is 12 meter. Okay, 12 meter is the span. Okay, and the density of concrete can be taken as 24,000 Newton per meter cube. Okay, so now this is what he has given. Now we shall try to solve this problem now. Okay, see now area can be now easily calculated. 200 into 600 mm, 200 mm by 600 mm will give this thing area. So WD, dead load, can be now easily calculated. Am I right now? It is 0.2 by zero point 0.6. Okay, 0.2 by 0.6 and 1 meter along the span. Okay, along the span 1 meter, it will give me the volume. Volume into density of concrete will give me so much. Okay, also he has given the live load WL. Okay, WL in sense now live load is given as 4000. Okay, it's there now. So 4000 Newton per meter. So now if I add these two, it will give me the total load. Okay, it is so much. So now, but now once I know the total load here now, okay, I think I can easily calculate reaction RA and RB. Am I right now? Reaction RA and RB can be now calculated as WL by 2. So W I know, total load, span I know, 12 meter divided by 2. It is so much. Reaction RA and RB is so much. Okay, see now. So now I have to consider the section at the support section, because at the support section your shear is maximum. Am I right now? So I have to analyze the cross section at support. Am I right now? Because at cross section at the support section only the shear force is maximum. Is it or not now? So I am considering the support cross section. So as you know, now reactions have been calculated. Baba, this reaction itself is the shear force here now at this support cross section. Is it or not now? So I have written RA is equal to RB is equal to the shear force V. Am I right now? So the shear force V is exactly equal to the reaction. Am I right now? Okay, that's one thing. And as you know, since the cable is laid parabolically and since it has got some inclination, okay, the cable carries some shear force. Is it or not now? So we'll try to calculate the shear force carried by the cable. Okay, see now, for a parabolic cable we have tan alpha is equal to or sin alpha is equal to 4h by L square into L minus 2x. See now how it has come. I will now explain you. See now, for a parabolic cable, just please try to understand here now. I have written here now, for a parabolic cable, the equation of the parabola is y is equal to 4hx by L square into L minus 6. I think this equation you know. Am I right now? This is the equation for your parabolic cable. I think you have studied in your maths. Y is equal to 4hx by L square into L minus x. Now I will differentiate it. dy by dx I will take. Okay. This x I will take it inside. It will become Lx. And if I take x here now, it will become x square. Okay. So now if I differentiate it, dy by dx, 4h by L square, you take it outside. this becomes L, Lx will become L, and x square becomes 2x. Am I right now? That's why dy by dx will become so much. 4h, 4h by L square into L minus 2x it will become. Baba, dy by dx means it is tan alpha, it is the slope. Dy by dx is the slope. Or in trigonometry, I will call it as tan alpha. Or since the slope is very, very small, tan alpha can be taken to be equal to sin alpha. Am I right, sir? Now, so now this is what I have written now here now. Okay, for a parabolic cable, okay, after the differentiation, I will get the slope. Is right or not now? Okay, now at support. Now, as you know, I am analyzing the beam at the support section because the shear force is maximum here. Okay, at support section, as you know, but now x is equal to 0 because the origin of the parabola is now here now. Origin of the parabola is now here. Okay, so now x is 0. X is 0 here, and if I travel in this direction, okay, if I come up to here, x becomes 6 meter. If I take up to here, x becomes 12 meter. Am I right now? Okay. So at support, x is equal to 0, as you know. Therefore, Baba, I want to calculate this term. How much is the value of tan alpha or sin alpha? Okay. Baba, x is 0, as you know. So x, when it becomes 0, this term vanishes. So this will become 4HL by L square. L will get cancelled. It will become 4H by L. Am I right? So sin alpha is equal to 4H by L it will become. Baba, 4 I know. H is this dip. Am I right now? Or this sag. It is 100 mm or 0.1 meter divided by L is span 12 meter. Okay, it will give me so much radians. It is the slope or the sin alpha value. Okay. Okay. Now, since the cable is curved, the shear force carried by the concrete is Vc is equal to V minus P sin alpha. Am I right now? So now, this is one equation. Am I right now? Oh, sin alpha, just now we came to know it is so much. Okay. Now see now. If shear stress tau v is to be 0, Baba, in the problem he has stated very, very clearly. Okay. See now, I will read the problem once again. Find the effective pre-stressing force necessary in the cable for 0 shear stress at the support section. For 0 shear stress, if at all you want to make the shear stress 0 here at the support section, how much pre-stressing force you have to apply? That is what he has asked. Okay, see now, in a sense, shear stress means tau v. Tau v should become 0. Baba, the equation for tau v is, please try to observe, tau v is given by VCAY bar divided by IB. Am I right now? This is given by, this is the equation for tau v. Now what he wants, tau v should be equal to 0, he says. Baba, when the tau v will become 0, see now, AY bar cannot be equal to 0, I cannot be equal to 0, B cannot be equal to 0. The only possibility here is now, Vc should be equal to 0. When Vc becomes 0, tau v becomes 0. Am I right now? So now that's what I have written. If shear stress tau v is to be 0, Vc should be equal to 0. Am I right now? This Vc should be equal to 0. So now from this equation number 1, okay, now I will put here Vc is equal to 0. When I put Vc is equal to 0, V I know, okay, the shear force I know, okay, it's here, it is Ra or Rb or shear force I know, pre-stressing force I want to now calculate, okay, and you know that sin alpha value is now 0.333 radians, okay, so you have calculated how much is the pre-stressing force required to make tau v is equal to 0. So if you apply this much pre-stressing force in the cable, your tau v automatically becomes 0. That is what he has asked. Okay. So now another thing what he has asked is, he has asked to find out the corresponding principal stresses. Okay. See now when the tau v becomes 0, he has asked you to find out principal stresses. Okay. Now But now consider the element at the centroid as usual. So now I can write sigma x is equal to f by a plus or minus fey by I plus or minus mty by I. Am I right? But since you are considering the element at the centroid, y becomes 0. So when y becomes 0, this term also vanishes, this term also vanishes. So I will be left with sigma x is equal to f by a. Okay, sigma x is equal to f by a only. Baba, f I know, area I know. So sigma x becomes so much. And since vertical precessing is absent, sigma y is equal to 0. Okay, so now sigma x is equal to so much, sigma y is equal to so much, and your tau v is now equal to 0. So now I think with this, I think you can easily calculate the principal stress. Principal stresses he has asked. Okay, principal stresses is sigma x plus sigma y by 2 plus or minus this much. If I take plus sign, I will get one principal stress. If I take a minus sign, I will get another principal stress. Okay, sir. Now, so now if you fill the values, you will get two principal stresses. Okay, this plus this will give me one stress, one principal stress. This minus this will give me another principal stress. Okay, that's what one of he has asked. Okay, thank you very much.